Hello and welcome to Bug Free Productions. Remember to subscribe on YouTube at Bug Free Productions and follow on Twitch at jib@bfp. So, let's begin. Alright, let's get started with the Singleton. So with the Singleton, I'll just go back to my VS Code and I'll scroll all the way to my Singleton, or maybe I'll go to my clock and we'll go to the Singleton. So you'll notice in where I used it, the clock manager, Singleton has the type passed in of clock manager. So this clock manager, while inheriting from Singleton class, is passing in itself as a type. And we'll see why that's important in a second. So this type of Singleton is one that I found on Gemini up until just surfing the forums. I didn't find one quite like this, so I don't know where this one came from exactly. There wasn't like a citation on that, even though Gemini is trying to do citations for different information. At least trying, maybe. But so I'm not sure where this exact one comes from. Usually when I see the type, it's still a singleton, so like this instance is not a singleton, or is a singleton class. It's not the type that gets passed in, so this is kind of new to me and kind of interesting, just being able to do it this way. And I don't use generics a whole lot, just because a lot of times they end up using a lot of extra effort to make work. That's why my factory item and my pooling system is all just kind of inheritance based, because I just didn't really want to deal with generics. But it's perfectly fine to use generics, and what we mean by generic is this type could be any type. It's just a generic type that gets passed in and is treated as that same type, and we don't really have to worry about what type it is because we simply are not worried. So at this point, we're just going to tear down how this looks. So this singleton is a mono behavior. So we need to pass in a type of mono behavior, and it is also a mono behavior. So easy way to read this line: public abstract, so we cannot create it. So we're creating an abstract class. It's not what we wanted. There we go. So this is an abstract class. That we cannot instantiate. And what's good about this is it forces us to not use a singleton class as is, but rather the type that we pass into it. Which is kind of important because, like I was talking about like a couple seconds ago, if this instance was a singleton type, we would then only be able to have one singleton total instead of like an audio singleton, a game singleton, so on. So we have an abstract singleton type that we cannot instantiate. We have the type, so we pass in the type we want. And this particular class makes that type into a singleton. So pass in type we want to make single. And we are declaring that this singleton will be a mono behavior. So that's just a Unity thing. It inherits mono behavior, meaning we can place it on a game object as a component. and then where type t, so where t is also a mono behavior. So we can only pass in mono behaviors at this point, which means that, which is important in Singleton, because if we were doing this as a standard C# singleton versus a mono behavior singleton, we would handle them entirely differently. Which we'll see when we get down to instance. So private static T instance, this instance is of the type we pass in, which is very important. And then application is quitting. This is a editor / unity check type thing. This is specifically retaining to handling when application runs.quit. But the most important part is persistent. So this is just another thing that we use to set it up. So if it is persistent, we want it to not be destroyed on scene cleanup. So we make it persistent. Which yes, they did implement. This one hasn't been fully implemented or validated yet, so you're kind of seeing it a little bit live. So then we have public static T. So we have the T instance. So this is how we access our private instance here. It's worth noting that you'll usually see me use protected instead of private. Well, that's not entirely important here, because we just don't really inherit this thing in the traditional sense. Like, we're not going to be using this instance from something else, you know? So if application is quitting, run null. So just don't do anything on application quit. Instance equals null. So if the instance is null, we want to create an instance, right? So we try and find first object of type. So if we can find it, then we check if it's equal null, we want to create one. So if we don't find anything, we want to create one. Singleton game object, instance singleton object. Finding first object. So this is assuming that our designers and developers do this well and only ever place one of these in the scene, which may or may not work, but we'll get to that in a minute. So it might be beneficial to like try and check if we are this instance as well. So once this part might get replaced is what I'm saying. But if it is null, then we do want to run this. And then protected void on awake. If instance equal null, instance this T. So we're casting the instance we have into a type of T. So this singleton basically will be treated as the type that's passed into it. And if persistent, do not destroy on load game object. So if we marked it persistent, it will add itself to don't destroy on load, and it will continue between scenes. Else if the instance is not this. Okay, so here's our check. If instance is not equal this, then we destroy the game object. So on awake, okay, so here's our check. And then that works. So we check in our awake, and if we have an instance that does exist that is not equal to this object, we destroy. And if it's null, then we add ourself to it. And then we protect, void on application quit. So this method runs on application quit. Set that to true. So this is just to handle our application quitting. Sometimes there's some memory stuff that we need to clean up, so this is a good thing to have for this type of object. And then we have on destroy, so protect a virtual void on destroy if instance equal this, instance equal null. So when we destroy the object, we clear our instance variable as well. So that's kind of nice. This was said to allow for multiple objects to inherit it, or not inherit. Said to allow multiple objects to be made a singleton using this class. So we'll see how true that is later. But for right now, this looks pretty good. It sets up, it runs. So far it runs as advertised. So we're going to continue this one and see if we need to change that later. After reading through it like this does look pretty good. And the reason we have to do this is because we are looking to make sure in our clock script that our clock manager only ever has one object. Because if we have multiple clock managers calling singular clocks and updating them twice per frame, it's going to mess up our timing. So we need to make sure there's one clock manager calling the multiple clocks to keep everybody on time and in sync. So that's pretty much the singleton pattern. If you have additional questions or want to see an additional example, feel free to drop it in the comments or in the chat, and we'll move on to the next set. We'll also revisit this later after I do some testing and maybe some re-implementation of it in older classes, and we'll see how it goes from there. Thank you for joining us at Bug Free Productions. Remember to subscribe on YouTube at Bug Free Productions and follow on Twitch at jib@bfp. Have a bug-free day.